Hello and welcome to Dove Biology, APES Lessons to Go. In this video we'll be exploring nuclear energy. Today there are over 400 nuclear reactors helping provide energy for various nations, including the United States, France, and Japan, which have the largest number of nuclear reactors. Nuclear energy is provided by nuclear fission, where energy is being released through the splitting apart of uranium nuclei by bombarding them with neutrons. Inside of a nuclear fission reactor, isotopes of enriched uranium-235 undergo controlled nuclear fission. This takes place inside of a reactor core. Control rods are there to absorb excess neutrons to regulate the reaction. Water heated by fission will circulate through the reactor and produce steam that will then spin turbines to generate electricity. That water is then cooled and then recycled so that we can continue the process. Now, the power plant is just one part of the nuclear fuel cycle. First, the uranium must be mined. Then it must be enriched to increase the amount of fissionable uranium-235 material that's present. The uranium-235 is then placed into the fuel rods so that it can be used in the reactor to produce electricity. When nuclear fuel reaches the end of its useful life, this highly radioactive material must be kept from reaching the environment for thousands of years and stored on site or at special storage facilities found throughout the United States. After between 15 to 60 years, reactors must be decommissioned. Aging reactors are subject to embrittlement and corrosion, and the longer they operate, the more chances there are that they could actually have a malfunction. Many reactors are actually applying to extend their 40-year license to up to 60 years, including 20 reactors in the United States. Now, there are many benefits of using nuclear power. A 1,000-megawatt nuclear power plant is only refueled once a year, whereas a coal plant requires 80 rail cars at least of coal each day. Nuclear power plants produce much less in the way of carbon dioxide emissions. And the mining of uranium causes much less land disruption as a result of surface mining. Now, in the 1950s, researchers actually predicted that nuclear power would provide up to 21% of the world's power. But as of 2009, it only produces 14%. And we might wonder why that is. Some of the causes are the fact that it costs a lot of money to build and run nuclear power plants. There is significant public concerns over the safety as a result of nuclear power failures like at 3 Mile Island and the Chernobyl nuclear meltdown. Additionally, from mining to production of electricity, there's a significant amount of wasted energy. Nuclear power is less efficient than other means in terms of generating electricity. So just how safe are nuclear power plants? Well, those in the United States are said to be well designed, operated by trained personnel, defended against terrorist attack, and prepared in the event of an emergency. Despite these claims, there have been many accidents. In March 29th of 1979, one of the 2 reactors at the 3 Mile Island reactor near Harrisburg, Pennsylvania, lost its coolant water and had a partial meltdown. Unknown amounts of radioactivity escaped into the atmosphere. The cost for cleanup? $1.2 billion, 2 times what it cost to actually build that reactor. The world's worst nuclear power plant accident occurred in 1986 in Ukraine. The disaster was caused by poor reactor design and human error. By 2005, 56 people had died from radiation release. 4,000 more are expected to die from thyroid cancer and leukemia. In 2007, a powerful earthquake in northern Japan caused severe damage to the world's largest nuclear power plant. In 2011, an earthquake and a tsunami caused damage to several reactors and a partial meltdown in one in Fukushima, Japan. Radioactive waste is classified based on the type of radioactive material present in the source and how long the radioactive material could cause harm to humans in the environment. The classification of the waste depends upon the source material's half-life. The hazardous life of a radioactive element is about 10 to 20 half-lives. Low-level waste is a byproduct of beneficial uses of a wide range of radioactive materials. These include electricity generation, medical diagnosis and treatment, and various other medical procedures. Some countries will place low-level waste in steel drums and then just dump them into the ocean. In the US, low-level waste is put into steel drums, super compacted, and shipped to 2 regional landfills run by federal and state governments. Currently, high-level radioactive waste, like that found from nuclear power plants, is stored at the nation's nuclear power plants in steel-lined concrete pools with water, or in massive airtight steel or concrete and steel canisters. Scientists actually disagree about the best methods for long-term storage of high-level radioactive waste. Many consider the idea of burying it deep underground, well below aquifers. Some suggest perhaps shooting it into space, while others suggest we find some ways to recycle it so that we can reuse some of the energy that's still left in that nuclear fuel material. In 1985, the Department of Energy proposed a storage facility in Nevada at Yucca Mountain. $58 billion have been spent to prepare the mountain to open in 2017. Based upon our current administration and the Department of Energy Secretary, that is definitely going to be postponed. Opponents say that site safety and national security issues with the plan really are at odds, and so we continue to search for a better location for storing all of this spent radioactive material. With an increasing appetite for energy and a desire to reduce the amount of carbon dioxide we put into the atmosphere, nuclear energy certainly seems like a viable source. Unfortunately, due to safety concerns over the use of nuclear energy and problems with long-term storage, we're given pause. Only time will tell if innovations in reactor design to increase safety, as well as an ability to utilize different sources of fissionable material or recycle and reuse our current waste products, will determine whether or not nuclear energy will become a major source of energy for our future.